Hello, today I am going to tell you how to use the various ivregress post-estimation commands. Now, in ivregress, we use the simultaneous equation. Now, what is the simultaneous equation? First of all, I will tell you that let's take an example of a demand and supply equation. This is the demand and supply equation. Here, this is the left hand side, and here this is the dependent variable, and all independent variables are this side, and this is the error term. This is the demand equation, and this is the supply equation. Now, here at equilibrium, demand is equal to supply. Okay, and means that this LD and LS, these will be equal at equilibrium. Okay, so now it is obvious that there must be some variable which are present in the right hand side and which are affecting the error term, and there must be some variables which are affecting the error terms of the second equations also. And here also you will find some variables, you may find some variables at equilibrium which are affecting the error term of its own equation as well as the upper equation. So such a equation is called as simultaneous equation, and for such equation it becomes very important to find the endogeneity. Now, what is endogeneity? In endogeneity, you may find some variables here in the right hand side which are directly affecting the error term, and if there are some independent variables which are affecting the error term, then a very important assumption of the ordinary least square is violated. That is, in ordinary least square, if you want ordinary least square to be applied, then your error term should not be affected by any of the independent variables. If there is any independent variable which is affecting the error term, it means that you cannot apply ordinary least square in such equation. Now, for such a situation, we have a second method, that is two-stage least square, and moreover we have another method, that is three-stage least square also. So now, first of all, we have to check whether there is endogeneity present or not. If there is no endogeneity present, then you can use ordinary least square. If there is endogeneity present, then you cannot use ordinary least square. So let's see. We will take a condition when at equilibrium your demand equation will be equal to your supply equation. So your demand is taken as the quantity as our variable. Okay, so demand is the quantity that was demanded by the bank, demanded by the company as loan from the bank, and supply equation will tell us the supplied amount of loan which was given by the bank to the company. So first of all, let us consider that the bank gave us as much as it was asked or it was demanded by the company. So now let's take the equation, and let's go to the Stata. Here in Stata, this is a panel data from 2011 to 2017, and we have these companies present here, and these are the various variables which we are going to use. Okay, now let's take, this is the quantity we have. Here we have the quantity. Okay, and quantity is the amount which was demanded and which was supplied. So now we will, first of all, we will apply here two-stage least square, and with the help of ivregress command, we will apply the two-stage least square, and after two-stage least square we will apply the post estimation command, and we will check whether the endogeneity is present or not. Endogeneity is present means whether the variables which we have taken as endogenous are really endogenous, or they can be considered as exogenous also. So now I will use ivregress command, that is ivregress to SLS, Then I will write the quantity because that was in the left hand side, and quantity is equal to, so for that, for now we will write the right hand side equation. But here what we do is, here we first of all write the quantity, and we will write all the exogenous variables which are present there, in the demand side. So now all the variables which are present in the demand side, which are considered as exogenous, are this is the first one, that is the sales. But that is this is the first variable, AP sales. Okay, so in the demand side, demand is dependent upon, demand means that is quantity, demand is dependent upon the sales, then it is dependent upon the cash flow, that is internal cash flow, then after that we have asset growth, then we have account payable, then we have net account payable, and we have return on asset also. So the demand, for demand side, in the demand equation we have taken exogenous variables as AP sales, internal cash flow, asset growth rate, account payable, net account payable, and return on asset. Here I had written quantity also, that by mistake I deleted. So quantity is dependent upon these exogenous variables, and now what I will write here, in the bracket I will write here the endogenous variable, and the endogenous variable I have taken is the interest rate. So interest rate is here, that is interest rate. These are the name of the variables I have given. And now for endogenous variable I will have to write some instrumental variables. So for instrumental variable what I have to do is, I will write the instrumental variable for this, and the instrumental variables will be the variables which are taken as exogenous variables in the supply equation. So I can show you here in this PDF file. Here, first of all, for quantity I will write here the demand shifters. So I have written the demand shifters, and here I will write the endogenous variable which I have taken as endogenous because I want to test its endogeneity. Okay, so I have taken this as an endogenous variable, and I will take the instrumental variables which can be applied in place of this price. and which are not affecting the error term, and they will be all my exogenous variables of my supply equations. And in supply equation I will do the opposite. For supply equation I will write the quantity here, then I will write all the exogenous variables of the supply equation, and for price I will write here all the demand exogenous variables as the instrument variables here in this equation for price. Okay, so now here I will write all the exogenous variables which I am going to use in the supply equations, and all these exogenous variables will be: the first one will be the age of the company, the second one will be the collateral, third one will be the solvency, fourth one will be interest cover ratio, and fifth one will be the assets. Okay, and I will close the bracket now. So I have here declared the various instruments for the interest rate. Now I will click here, and after that I will get the results here. Here you can see the instrument I instrumented long interest rate, and instruments were all instruments were these all are the instruments. Now I have to check for endogeneity here. To check for endogeneity means that whether this interest rate is really an is really a endogenous variable, or it can be taken as exogenous variable also. For that, what I will have to do is I will have to check for that endogeneity, and the command for that will be estat. That is, I'll write here estat endogenous, estat endogenous long interest rate. Okay, and now here you can see that it is test for endogeneity, and here variable, and the null hypothesis is that variables are exogenous. So here Durbin chi-square tells us that the p-value is 0.9646. It means that it is not significant. If and also here that Wu-Hausmann test also says that it is 0.9647, which also says that the null hypothesis cannot be rejected. Okay, so it is not significant and the null hypothesis cannot be rejected. It means that our variables are exogenous, means long interest rate can be taken as exogenous variable. So now if you want to test for the any other variable, for example, if we want to test for the, let's say we want to test for asset growth, so for that what you have to do is you have to again do the same thing. Here you are having ivregress 2 stage square and quantity AP sales. Here what you do is you put the long interest rate here, and put the account payable here, because now we want to check for the endogeneity of this variable. Now again we will do the same thing, and again we will check for the instrumented variable. Okay, so again we will use estat command and estat endogenous, estat endogenous. So now here what you see here is that your Darwin test says that it is 0.00 and the second test also says that it is 0.00. It means that your variables are means here it is significant. These are the significant values, and it means that we can reject the null hypothesis. So the null hypothesis is that variables are exogenous, and the alternate hypothesis says that the variables are endogenous. So now it means that the account payable variable account payable is endogenous variable, whereas the previous one, this one was not endogenous and it can be taken as exogenous variable. So this checks our endogeneity. Now if you want to check whether the various instrumental variables which you have used for this endogenous variable, if you want to check whether these instrumental variables are strong enough to define this account payable variable or not, for that you can test for overid. So for overid, it performs a test whether these are strong enough to check for your account payable to be a good indicator or not. For that you have this estat overid test. Here this overid test tells us that if your instrumental variable, here there are less if there are less endogenous variables and there are more in instrumental variables present there as compared to the endogenous variables, in such a situation we have the situation of over identified. So when your number of additional instruments exceeds the number of endogenous regressors, then we can test whether the instruments are uncorrelated with the error terms or not. So if the model is just identified, just identified means if there is one endogenous variable and only one instrumental variable is present there, such a situation is called as just identified. If we have a situation of just identified, there is then we cannot perform a test of over identifying restrictions. So this over identifying restriction tells us, this test will tell us whether these over identified instrumental variables are affecting the error term or not. Okay, so if they are affecting the error term, then these are not good instrumental variables. But if they are not affecting the error terms, it means that it is a good instrumental variable, because endogenous variable, instead of endogenous variable we are using instrumental variables, and we are using instrumental variable instead of endogenous variable only because of the reason that we don't want the variables to be variables in the right hand side to be correlated with the error term. So it is very important that the instrumental variables which we are going to use instead of the endogenous variable should not be correlated with the error term. For to test for this, we will write here estat overid and now this will tell us Here we have the endogenous, the this test. Our test will tell us test for over identifying restrictions. Here we have Sargent chi-square, which is 0.8590, and Basson chi-square, which is 0.8595. Now what is the meaning of these two? If these two p-values are significant, if these are significant, it means that either one or more of our instruments are invalid, or that our structural model is specified incorrectly. So now here you can see that nothing is significant. Both of the values are insignificant. It means that the instrumental variables which we have used for our endogenous variable, these are good instrumental variables, and these are valid instrumental variables, and our structural model is specified correctly. Now we have one more method. If we want to check whether this these instrumental variables are good indicators of account payable, that if we want to check whether whether the instrumental variables which we have used, they are sufficiently correlated with the endogenous regressors but uncorrelated with the error terms, then for that we have another method of checking it, that is called as first stage method. That is, we will use again the estat command, estat first stage. Now here you will see that we have this first stage regression summary statistics, and here we have minimum eigenvalue statistic, and after there we have the null hypothesis instruments are weak. Okay, now here what is the meaning of this r square? R square, if the value of r square is not significant, if the value of r square is large, the value of r square is large, it tells us that in the first stage of regression, adjusted r square, if the value is high for r square, it indicates stronger instruments. Okay, and instrumental variables estimator exhibit less bias when the instruments are strongly correlated with the endogenous variable. Now, but this is not the only indicator. Okay, this may be misleading also. We have one more thing, that is this f statistics. For f statistics, if it is significant, if the f statistics is significant, then it means that the additional instruments have significant explanatory power. If this value comes out to be insignificant, it means that these instruments which we have used instead of account payable, they don't have any explanatory power. Okay, and they cannot be used as instrumental variables in place of account payable. Okay, so this value, if it is significant, as here we have this value significant, it means that these variables which we have used as instrument variables, these are explaining this endogenous variable very well. Okay, now we have the next thing is minimum eigenvalue statistic. So here the minimum eigenvalue statistics is 1148.48, which is very high. a very high value of minimum eigenvalue statistics. What does it indicate? It indicates that we can easily reject the null hypothesis. Okay, if it is low, if your value for minimum eigenvalue statistic it is low, you cannot reject the null hypothesis. So here the value is very high, it is 1148 and it is very high. It means that we can reject the null hypothesis that instruments are weak. So the null hypothesis is rejected and our instruments are strong enough. So we have done 3 tests. The first test was that we want to know whether this instrument variable which we have used, it is endogenous, there is endogeneity or not. So this test has told us that there is endogeneity. Okay, so this is endogenous variable. After this we had the test for these instrumental variables. For these instrumental variables we did 2 tests, whether these instrumental variables are correlated with the error terms or not. So for that we did the second test, that is overidentifying test. So in overidentifying test also we got that the values are insignificant, p values are insignificant, and it is indicating that they are not correlated with the error term, which is good. The third was that they should well define the endogenous variable, because we are going to use these variables instead of this endogenous variable. So they should define fully this variable. They should be able to explain this endogenous variable easily. For that we did another test, that is the test for first stage, and this test told us that the minimum eigenvalue statistic is very high and instruments are strong. We can reject the null hypothesis and we can say that the instruments are strong enough. And here this value also indicates that uh, we can these instrument variables can easily fully define this instrumental variable. So these are the tests for endogeneity and are called as the test for these are called as the post-estimation test for IV regression. I hope this video will help you a lot, and if you like my video please comment, share and like it. Thank you.